Well, hi, good morning, and thank you so much for joining me in my shop. Today is January 12th. Maybe a little bit of snow is going to fall outside, and it's just a little bit below freezing. It's not that cold here these days. So, very good. The end of the last video I posted, the string broke on this radio, the dial string. So today I'm going to focus on replacing the dial string. But I was in here yesterday and I did do some stuff, but I won't be posting any of what I did yesterday. Yesterday I was continuing to fool around with my SDR radio, this one here. This is an early SDR radio. I've had this for quite a long time now, and it's always in my shop, and I use it mostly for identifying the frequency of a local oscillator in a radio like this. It's quite handy for that kind of stuff, but it has some crap in it, as you will recall if you watched the video. So yesterday I continued on with it, but I got so frustrated I brought in another SDR radio, this one here. This is also an RTL SDR radio. RTL SDR radios were really made as television receivers to pop into the side of your laptop so you could watch TV, but then television changed entirely and there's nothing for it to receive. And some clever guy figured out how to utilize them as a shortwave radio receiver, and so that's kind of how they've existed for a while. When these were first coming out, this is $75 or $50 or so. This was $50. Then I have this one here. This is a much more purpose-built SDR, if you like. This radio, boy, this is an awkward radio to operate. But I was able to spot the local oscillator and compare the screen display to the other two. The end result is these radios have problems. These cheap ones have problems, no doubt about it. So, but it doesn't restrict them from being used. You just have to be careful about what you're interpreting. So anyway, that's what happened yesterday, just discovering the realities of using those SDR radios and that. So, but let's go on with the string replacement. So in this radio, to do this plate has to come off. And I think it's held on with just a couple screws on the front here. You hear some thundering sort of sounds. It's quiet right now. That's my two young cats playing upstairs right above us. There we are. Wait a minute. Oh, it's definitely broken. So it's off the wheel, so I don't have a chance to see how it's done on the wheel. What is going on here? The string has a hook here. The string not come down into the middle? I don't think it did. So there's a slot here where the string is disappearing just in there, and a slot over here for it to come out. Yeah, I think it just goes around the wheel. I don't think there's any wow. Something sticking out right here. What is that? Let's take a closer look at the wheel here. Okay, you can see my camera there. Let's look through it. And see some curious things right away. This is a little odd, and so is this black stuff coming through here. This is a little odd, but I already know what it is. If we just look here, you can see that what they did was they've got a black plastic piece that's somehow fused to the shaft. I'm not sure how they've got it stuck on the shaft, and that's to keep the wheel from turning independently of the capacitor shaft. So it needs these wings coming up here to give it some kind of strength, I guess. I'm not sure what the right word is there. Stability, strength. Okay, now what's missing in here is the places where the string would terminate or a spring would hook up. There's no clips in this at all. So again, that suggests the string's just on the outside, which I don't know if I've ever seen one where they just have the string on the outside of the wheel. So we'll take a look at the wheel here. Let me just tighten up the focus a little bit. Just bear with me a moment. There. Okay, so this would be the running surface, if you like. Just out of view of the camera is something curious, so I'm just going to tip it up here. That. So that's a typical opening through which you would pass the string to come into the center. And see, they've left a flap sticking up, so you can imagine the string would approach from this side and go down, and would never pass this spot. The string will never go by this spot. Really? You know what? I got another idea about that. It just came to my head. Let's just see if there's anything else like it on here. Watch that. Sorry, I'm a little shaky here. Let me just steady up more. I think that's just dirt in there, isn't it? Yeah, it's just dirt. It's nothing. So we have one tang sticking straight up. Now usually when this is the tang here, usually these things are punched through onto the inside and then swung out of the way, bent out of the way. Why is this sticking straight up like this? In my thinking, my idea is, let me just get the remnants of the string here. My idea would be that the spring is sitting right on this thing, like this. This is my thinking. This is what fixes the string. I don't really need to fix, like the string doesn't have to be fixed in place to keep the radio tuned properly, and not in this one. But you don't want the string slipping around the wheel, so it needs to be attached to the wheel somehow. I'm thinking this is how it's done. So that forces the position of the spring. Now, it looks to me like that's the other end of the string. I mean, for sure it is. Now, can I deduce? No, I cannot. If the string had broken when the wheel was in an extreme position, I might be able to figure some things out here. But what I was thinking was, okay, if you put a string, if this reached the end there, then obviously the spring will go on the string here and would sit on that tang. But this can turn all the ways. But that's got to be what it is. What else can it be? What else can it possibly be? So this only moves at 180 degrees also, because the action of the capacitor is only at 180 degrees. Pointer, if you can think about it too, also swings 180 degrees, obviously. So that's one limit. That puts the tang there. The other limit's going to just be the other way, down here. What does it all amount to? That's a good question. Let's look at how the string is put on around the bobbin on the control here. I think sooner or later I'm going to break that antenna one way or another. dark in my shop today. Well, here it is. When I want to figure out how many times around. Wow, how many times around was that? Looks like it broke right in here. If there was a string guide, you know what? I've got the string guide book. Maybe I should take a look. Because guessing these is not the wisest idea. This one's really, really simple though. So I'm just trying to clean up the surface of the bobbin here. So this has got the Glacial Valley style bobbin. I call this a bobbin. So it's intended for the string to continually slip into the middle of this bobbin area, which you can't really see very well. It's still hard to see in the camera, isn't it? The shape of it here. But anyway, probably once completely around, maybe 1.5 times around is probably what it's looking for. I wouldn't imagine too many more. Now, where's my string? Here it is. So I've got some dial string here. This is a string that has no stretch in it. There's no stretch at all. A little thin. A lot of dial strings are quite a bit thicker. Like the original one is quite a bit thicker than this one. This one being thinner, I can go around maybe even an extra loop in there. Well, that's tricky. You got to fish it around in and through. So I got to get the order right, number of turns right, the positioning of the ends right, so the spring. So that's not too tough. That's really not too tough, because you could put the string together and then you could spin the wheel and move the string and the spring and everything around until it finally got to where that tang is sticking out. So it's actually not, this is actually not too critical here, I think. It's probably famous last words happening there. Okay, let me take a little break and then I'm going to stick that string on there. Okay, I think I'm ready to take a real shot at this now. So I don't want to cut the string until I have to, because I grew up with very frugal parents, and you didn't want to waste any string, let me tell you. So I could wrap from the back around to the front, from the front around to the back. It can wrap around this way or wrap around that way. It's got to wrap around the right way. So we want this to turn, and when we turn it like this, we want this guy to turn the same way. It's kind of obvious how this has to go. This isn't complicated. So if I want the string, it's either over the top or under the bottom. That's really what has to be decided. So over the top would be the right way. So I want it to come in from here, go over the top, around and out at least once. Let's come in from here, over the top. Ooh, I gotta get my my specially adapted string tool here. Get it. There we are. Yeah, keep it in a very handy place, as you could hear. So this has a what I call a pusher puller, and the other end of it is just a hook. So I just bent it into that shape. So okay, and we want to have this guy go down and around, and then we want it to come up through again. How am I going to do that? Come up behind. that's once around. I think that's enough. A lot depends on the tension in the string, and this string could be tensed up with that spring a lot because it's not doing much. There isn't a lot of pulleys involved or anything like that. Okay, so is that going to fall back under? It won't now. Okay, so obviously the string is coming up this way and coming up this way, and then there it's attached with the spring. Now, should I use the same spring? It's pretty rusty. It's sprung open a little bit now. I got two minds on this. One is it's just a spring. Of course you can use it again. There's a limit, of course, to a spring where instead of just stressing the material, you eventually strain the material. Straining a piece of metal means, well, if you stress a piece of metal, so you apply stress, when you let go of the stress, it goes back to exactly where it was. You haven't deformed the metal. If you strain the metal, then it only goes back there, because you've actually bent it or disturbed the metal in some way. So, you know, this can be pulled out a certain distance and a little bit further, and it's stretched permanently. Well, let's put the old one back in. Whoops, whoops. Ah, almost had it. Okay. One end. Now we have to estimate the length. You have to determine the length at this point. So I would want the spring to be stretched a short distance. I need a marker. Here. The spring to be stretched out. About here. Okay, I'll cut the string. Too many times I've cut strings like this too short. Trying to preserve string, and then they end up this is just a little short piece of string here, but some of these radios, especially European ones, there's a lot of string involved, and most of the tension ends up not in the string but in you trying to do this. This radio is easy. In fact, I don't know if it can get much easier than this. Some radios do not have a string at all. Those would be the easiest. Okay, we got the knot right on the blue mark. Did he do this right? Wow. Okay, hang on. You know what I'll do? I'm gonna. Oops. I'm gonna put it on. Lay it over. Oh, wow. That's a little tighter than I thought it was going to be. You can hear it tightening up there. There we go. Wow, that's on tight. Now, the tang is here. And see, the spring is heading down for the hole. So we want to slip the whole thing, which I think can be done pretty easily. Probably by pushing the string rather than pulling it. Yeah, I can't push it past this. What about put the spring up here and then try to turn the wheel under it? That might be easier to do. Yeah. Okay. So I really did get this much tighter than it needed to be. So we just want it to engage anywhere on the spring. Because it'll lock it. There we are. Locked in. Well, this string is not going to slip, that's for sure. If you put the string too tight, it can, and I think maybe this is happening, it can cause the wheel to tip from the strain of the string pulling on it. And in some cases it'll tip far enough. This one's not going to tip far enough. Tip far enough just from the force of the string pulling on it that the string will dismount here. It'll find its way off, but that's not going to happen in this radio. I can look at the alignment here. And yeah, it's not going to come off. There we go. Okay, we're back in business with this radio. Now, I think this is all I'm going to do today. And tomorrow we will attend to, ooh, look at this wire, oh my gosh. Yikes, don't even touch it. It's just fracturing, just don't even look at it. It's going to cause a short right in here. It's virtually there now. Oh, I got to put the plate back on. So you see the all the cracks in the, yeah, I can see them quite clearly on the camera. Do you think that was original and they wanted it to look like that? I kind of think so. Then there's an even finer surface here. I don't know. Okay, should I bother putting this on, or should we just leave it off for now until... I'll leave it off till later. Why not? I'm done for today. Well, thanks a lot for watching, and it was a pretty simple, this is like the simplest, one of the simplest string jobs I've ever done. And good. So you enjoy your day, I'm going to enjoy mine, and playing around with radios a lot these days, and having a great time. See ya.